data where it resides. We are not taking all of that data and putting in one Google server. We have heard of Google farms where there are no servers, there are commodity machines going on. And that's the way big data analytics operates. It really takes the functions to the data rather than the way you used to do where all the data is taken to the function which somebody ran at a huge cost. So I think that's something which is changing. Large scale data analytics, right? So as I said, the volume of the data is really increasing, so we really cannot really use the traditional methods to analyze it. And finally, the data analytics and the business intelligence problem, I think in the last, before big data arrived, was more an offline function. The CFO, the CXOs used it for forecasting, predicting, understanding what happened. It was more a post facto analysis, but now with data moving at such a rapid pace, everybody wants real-time analytics. I think that is the reason as well where traditional conventional methods will not suffice, because you store something in one big place and then run analytics tools. It is no longer the norm, because there are customers coming in, going out. You really need real-time feedback so that you can take online actions on what's happening around in your environment, right? So I think that's something which is really changing the definition of analytics. It's becoming more real-time rather than the offline mode that it used to be run in, right? So these are the patterns changing as we move into big data, right? I did mention this. So the 3 V's, and of course complexity there. You also see the different types of data sources contributing to these 3 V's. I think this is a very good slide to remember when you define big data, and also then learn by analogy on the next level of detail around what big data technologies are used, right? So as I said, the traditional methods of storage are not going to be really useful for retaining this data, and it's really not going to be just a single huge server for which you pay a bomb, right? So different new data storage structures have been devised by the Facebooks, the Twitters, the Googles of this world, and that is where the RDBMS theory of RDBMS is also changing. So it's no longer R, right? So it's going to NoSQL databases and things like that. So the structures that you see are also changing. So you, instead of just the row column kind of structures that you designed for your databases, they are becoming more easily accessible. For example, Google, we primarily use it to retrieve information, which is in technical terms is a read kind of a task. So you have to design your databases and the big databases for faster access to information rather than writing information or doing transactions. And that's the way these data structures have been designed, so that you access information faster, whether it is video information, whether it is social feeds information, whether it's WhatsApp messages and all of that. And that's the technology revolution that has happened to really make sure that whatever data that we are producing on our smartphones is being stored in some of these different storage mechanisms, right? So that's the technology change that's happening. And this is the solution for the huge data. So I think as the maturity model of where data is moving from, right, as you can see, we had aggregators, we had BI, we have data warehouses, and that's where we were, right? So aggregation was analytics, right, and then produce some reports on that. But I think what we went then was we got cool products which gave you very nice visualizations, graphs. I think that's where the industry then matured. And we had some really fancy looking charts, etc., which you could take to the boardroom and show all of your senior leadership. I think that's where, and it was really useful for taking big decisions post facto after analyzing a lot of data. But I think as we move in the last few years, we have a lot of statistics folks, and I don't know if there are a lot of statistics department people out here, but the data space has now also become the really the ground for people with a lot of statistics and probability backgrounds. And you hear the terms data scientists and machine learners and all of that. I think that's where the BI world has now started changing, and it's become from from prediction or predictive analytics, right? It has become now prescriptive, and then also now coming into cognitive analytics, right? And that's the advancement that's happening with and the base of all this is the big data technologies that allow you to really analyze all of this data in real time and do much more than just forecasting, right? And where we are going with this is, of course, artificial intelligence, machine learning. I'm sure there are some sessions around this space as well. But I think from the technology perspective, this is where the whole big data analytics space is moving towards. We have a few case studies and real life examples from across the globe, which Ranjana madam will really highlight how we apply these to real life problems and what is the opportunity out there in this field for us. Over to you.
Yeah, thanks, Nitin, and thank you for giving me this opportunity to be here. Another warm welcome to all of you. So just taking it forward from when Nitin left, where does the rubber really hit the road? You have all these technologies. What do we do with them? How can we apply them? How can we improve the lives and the way of working of our businesses, our enterprises, and the way we live, right? Unless we know that, unless we are able to get us this outcome, this world will not move. So in short, how do we make money with this technology, right? And here are a few use cases which I would like to share. Some of them I have lived myself, and some of them are from other industries where we work on. So let me start with the first one. Now these are a sample of where we have used our big data technologies, and as you can see, if you look at the extreme right, you will see the different industries in which big data is applied. And this is just a sample. I was just talking to our respected Vice Chancellor. He comes from the field of biology, and biology is also a field where big data is applied, right? So these are some of the examples where we as Accenture have worked, and as you can see, it will be examples in health, right? Health with the number of diseases, number of patients, number of geographical areas where you get viruses, whatever is the weather, everything applies there. You can use big data technologies for that. You can use big data technologies for medicine research. You come to unstructured data, as Nitin was mentioning. It was about email, about Twitter, about any other form of social communication. And how do you really make sense of what we are bombarded with every day and what we participate in the social media every day? How is all that information really, what's happening to that information? Is it just a tweet? Is it just a SMS? Or somebody is doing something with it, right? Customer. Everybody wants to make money. We need more revenue. What do we want to mean by that? You can only get more revenue if you hold on to your existing customers and grow your customer base, right? So how much ever you can analyze your customer related data, and there's plenty of it in structured format, in unstructured format, within enterprises, within government systems. How do we and what do we do with that data, right? So that is where we sometimes call it a 360-degree view of a client or a customer. That is where big data becomes important. Of course, you can do it in finance and risks and faults and frauds and just normal core banking transactions, right? And then, of course, resources. That's a data guzzler. Be it oil, be it natural resources. How can you really make use of all those sensors? How can we keep lights on at production facilities where we are drilling oil or where we are developing gas solutions or chemicals or whatever, right? So there's a huge plethora of industry use cases where big data really applies. And not to forget telecom. With the number of devices we have, with the number of applications, with the number of, if you see the number of different ways in which we receive data, be it wireless, be it fixed line, be it broadband, be it cable, be it whatever else. So the whole huge telecom industry is again one place where big data can be applied. So let us look at this. This is an example of a large company which provides services by hosting a platform, a cloud platform. And what do you do really with a cloud platform? You provide storage services, you provide security services, that kind of thing. Now it could be, we know of Amazon Cloud, we know of NetApp, we know of different clouds, entity. What do you want to use? Most of the telecom companies, we have a Reliance data center which also offers a hosting platform, right? Now what happens with this hosting platform? You have many enterprises who are the users of this hosting platform. There's a huge portfolio of services which this hosting platform gives to its B2B and B2C customers, and you need to analyze it. And the more customers you have, the more data is generated. The more data is generated, the variety of portfolio of services which a hosting platform can provide improves. And which means that you have to keep this platform going. You have to make sure, why do people come to a hosting platform? Because they want speed to market, right? They want to immediately start up their enterprise and start delivering services. Now, if you are not able to configure and deliver those services when the enterprise expects it, what's going to happen? The customer is going to move. If the customer is going to move, what happens is your revenue channel goes, right? So ultimately, this hosting platform was growing double-digit growth, did not really know how to manage its services, neither its growing client base satisfaction was going low, and that's where big data came into picture, right? And that's where we provided a solution. Customer engagement improved, quality of service improved, SLAs improved, and the company is still doing very well, right? This is an application which is now being replicated across, and now we have an industrialized framework on how we can really get and help our customers grow in terms of when providing hosting services. And the topic here is also cybersecurity, where again this becomes extremely important along with big data. Here is another example. Video streaming. Think Hotstar, right? Think Netflix in this situation. Now, as we know, video data is extremely heavy, extremely dense. You need to have good bandwidth. The quality of video has to be extremely good. The experience has to be extremely good, right? Think of an IPL match, India-Pakistan. The Hotstar service which we put into place for Star India is a very good example here, right? What do you mean? You mean your subscribers are growing. When the match is on, you should be able to scale your resources without depleting the quality of service you're providing to your customers on different devices with different bandwidths, with 2G spectrum or 3G spectrum or 4G spectrum. Is it complex? Bet it is. But you still have to provide that service if you have to stay in the marketplace. And that's what big data is. How do you analyze? Where is the load coming from? How do you distribute it? Where is the quality of the video getting into a problem? Where is more buffering happening? Do you have to increase your resources to make sure your video? Is it only the CDN like Akamai which you have to really monitor, or you have to go beyond and do network analytics? You have to do operational analytics, and all that has to be real time. Nobody is going to sit with you and say, okay, I'm going to watch the match later, or nobody is going to subscribe to your service if they are going to lose it, right? So this is where the challenge, complexity, volume, scale. That's when you say, yes, a big data solution will apply, right? Large telecom. Nowadays, telecom are also growing their business. They're increasing their revenue challenge. They are also tying up with retailers to give different offers. And here is an example. Huge customer base, 10 million in North America. 10 plus million subscribers, 40,000 to 50,000 offers across different retail stores to be provided. Think Thanksgiving or think Christmas, pre-Christmas shopping, right? And at real time, when somebody subscribes to you for that offer, you should be able to narrow down from 40,000 to about 2,000 to 3,000 real products, brands, based on the customer profile of your subscriber, a telecom subscriber. Give him the offer and close the deal. Make sure your retailer, who you have a contract with, is earning money and you are also earning money. And the client and your subscriber is happy. Is this complex? You bet it's complex. Does it have to be real time? Yes. Do you have to use predictive analytics? Yes. So when you have this kind of situation, that's where big data applies. Does it need to be secure? Yes. Right?